Welcome. I'm Mr. Rogo, and welcome to Robotics and Electronic Automation. The future is automated, and that's what we teach in here. We teach all about automation. Where do our students go? They go to Tyson. Yes, we have people at Tesla, OG&E, out in the oil patch, Coke nitrogen plant, a variety of industrial companies here in Oklahoma, in northwest Oklahoma. So we're going to show you around. It's going to be really rough and unedited. And we're just going to walk around and show you some of the equipment we've been working on. So come along. First thing we're going to do is we're going to go over to the AC/DC trainer. And we have some first-year students over here who've set it up. All right, Dominic, take it away.
All right, so we have a 24-volt power supply going into a selector switch and into a lamp. And you just turn it on, put it on DC, and then turn the selector switch, and the lamp should turn on, just like that. And then you can turn it off like that. And then always make sure before you close off this area, always turn it off first, and then take everything apart, and then put everything nice and neat.
So Dominic, we start off with the student knowing nothing. We start with how a flashlight works, and then we work our way up from there. Everything we show you is going to be starting off from the beginning. John, I think it's your turn.
Oh yeah.
I'll grab this. And John is cameraman here, and he has a voltmeter, and he's going to show us how to use a digital multimeter to measure the voltage coming out of the wall.
This is with the voltmeter. You always want to keep your fingers right at the edge of here instead of above. This is where you change your numbers for your AC, and then your DC will be over here. I'm going to start off with 200 because I know it's going to be an overload on 20, which is OL. And it starts giving you a reading about how much it gives. Oh. About 120 or so.
There it is. Got a good contact in there.
Yep. And if you wait till it counts down to 0, and turn it off. If you go to DC, it should give you a negative reading. It's a little minus. Well, minus there is what it means it's negative.
So it averages out to 0.
Yeah.
Okay. Well, thank you, John. We're going to go on now to Kyle, and let's see what you got.
We got a little bit more complicated circuit. We're using 12 volts. It's going into a selector switch, to a push button, to a buzzer, and to a capacitor that stores energy. So when we turn it on, nothing happens. There's no energy in that. So we open that. Now there's energy stored in here. Then we close this, and we just push the button. Noise.
All right, let's get a little closer to it. I want to hear that again. I want to hear that capacitor discharging on this buzzer. Let's do it one more time. All right. And this was an example of the circuit that he built. All right, well, thank you, Kyle.
You're welcome.
All right, we're going to walk on around over here to motor controls. We have a lot of equipment out here we're not going to actually have time to show you. This right here is our Fanuc robot. It's the smallest industrial robot that Fanuc makes. It's a beast. It's made out of metal. If you see a commercial with that color, that's our robot. We have other equipment out here. I know the camera's probably not picking it up too good. We have a lot of stuff going on. So we're going to come on over here. That's a hydraulic trainer. There's a motor control trainer. Looks crazy, I know. This right here is supposed to be a solar energy trainer. But over here is where we want to be. This is Lucas. Introduce yourself.
My name is Lucas. This is the motor control station. You'll start with simply learning how to walk out and tag out like you normally do out in the field. Then you'll go up. You'll start learning all these different stations, how to operate them, how to plug them in. You'll be using these little connectors hooked up to just like terminals, kind of like plug and play, but it simulates actually like screwing them in with actual wires. So you'll start learning how to like set up different circuits and like put them in there in different ways and all kinds of different things. And basically, you learn to start up the motor, all kinds of stuff. You can learn to push it, stop it. You'll learn to do all kinds of stuff like lock it to where you can hold it, and then when you let go of the push button, it would stop. But I have a latch on it, which is a reverse contactor station. You'll learn about that. And yeah, that's about all I got.
Let's see your schematic, Lucas. Let's see what you built, though.
Oh yeah.
Let's see what this looks like.
But yeah, you'll start off with just a little bit of plug and play. It'll show you the picture of this, and you'll be able to just, you know, kind of follow it. But then it goes up to schematics like this, the ladder diagrams.
All right, anything else?
That's about it.
All right, let's head on over to Xavier. All the equipment you see in here, we also teach to our night classes. We have adults coming in at nighttime, do some training. So you get the hands-on with industry standard equipment. And what we have over here is we have a process control station, and Xavier will explain what's going on.
That's me. My name is Xavier, and what you're looking at is what Mr. Rolo said is process control. And what I'm doing here with this as simple as the bubbler. As you can see, if you come closer,
Yeah, zoom in, clear down at the bottom, they're coming out.
as you can see that this bubble is coming up, let you know that the air is pushing out, so that it could measure 2 inches from what it actually is. It's like, for example, this is 14 inch, but if you look over at the transmitter, it says around 12 because it is 2 inches from the ground. And once it's a really load of fun stuff to do. Like, you can mess with the hand valves, open it up and close it, but it's not on because it's off. So, like, for example, if I let go of one of the hand valves, you see here the bubbles drain. I mean the water drain. And over here is the power flex, where you can start the machine over there, and this little knob measures how much hertz it can take, so it depends on the velocity. And so yeah, that includes the process control.
So where is this stuff used around Enid?
Places like Coke and
In your oil and gas, mainly?
Any oil
Coke,
and gas and
nitrogen has a
stuff.
lot, oil and
Yes.
gas has it.
so yeah, that's pretty much what the process control does. And
All right, well, thank you, Xavier.
Thank
Come
you.
on around. We have additional training we're not using right now because our students aren't in those areas. Over here we have a mechanical trainer. We learn all about gears, pulleys, belts, chains. But over here, something I want to show you. This is called a modular production system. And this system is torn apart, put together all the time. So it's going to have some bugs in it. But we went ahead and fired it up for today. And it's going to move pieces around. And so I take what I call a hockey puck, and I put it in its starting position, and it's picked up pneumatically and delivered over to what's called a buffering station. It passed it on, since there's no more hockey pucks in here. When you adjust it properly, it'll push it forward onto the next station. This is called pick and place. Air pressure is used to create a vacuum and pick up this little dial indicator and put it on top. I had to push it there to line it up, but like I said, things aren't adjusted perfectly right now. This belt will push it forward into that arm, and it comes down and it stamps it, because this is a press. And then it goes ahead and puts it out here to the warehouse, if you want to look at it that way. And the warehouse should sort it. And I think it already missed its timing of what it should have done. This is the start. This beam right here is the stop, so we'll try it again. There you go. It looked at it. It looked at the color and if it was metal or not. And the little arm swung and it sorts it on the output. So each one of these stations has a specific function. And in the past, our adult students have gone in here and ripped everything off the top, dumped the program, take a shot of that right there, down here on the bottom, dumped that program out, and rebuilt it themselves. So you gain this experience here at Autry, you are well trained to get a good starting position in automation. All right, let's go next door. Kyle and Dominic. We have not, we're getting ready to start. We haven't started it yet, but these are the ground drones that we build. Whether the student will first build a four-wheeler, then a six-wheeler, before we go up into the air with the quadcopter. One of you guys, I want to show them how this thing's put together, because it looks like Legos, but it will not come apart.
Alright, so you want to grab like this tool. It has like a little ball joint in it, and yeah, on the other side here, you can put it in like that, and then if you turn it, that way, so slightly, you want to pull that out, and then you would be able to pull this out, but I would have to do it to this one too. To pull that out like that.
And that's how it comes apart. That's how the whole thing is put together. We've broken a lot of these different pieces before. That's why we put bumpers on it, because it's very rigid. It works real well.
To put everything back together, you want to put it back in and then just twist it to the right just a few degrees and then pull it out if you can. There we go. Put that in. There we go. And that's how all of that is made.
So the students haven't started it yet, but the project will be, I'll give them one that runs. They'll tear it down completely with no parts spared, left together. And then given the diagram only, they'll have to build it back together. They'll have the instructions. If they make a mistake, it simply won't work, something won't fit right, and they'll have to figure out how to put it back correctly. And so it's a lot of fun. We enjoy it. Looking here at the six-wheeler, you're not just gaining two wheels, you're gaining a lot of stuff. And so for the remote control, we have a transmitter. Grab that transmitter over there. So we sit there with a transmitter and to control it. And it's got a lot of controls on it. But this here is the receiver. The receiver talks to this controller down here. This is the part that can be programmed. This is the same part that's going to go in the quadcopter. This controls the robot. Here up front, we've added an array of sonic sensors. It sends out, just like a bat, it's echo. Like they use echolocation. It'll send out a signal, bounce off. It knows how far away it is from an object. So this is a sensor array. It'll talk to the controller. Student will have the program in the controller to make it run. It'll also know it's a GPS coordinate system right here. While it's running, it can send this data back to you on a transmitter on a laptop. So you can get data back as it's running in real time. You can program it to go between waypoint locations on GPS. So we want to solve these problems on the ground before we go to the air. Here we have the same system. It's the same flight controller, same GPS, but once you get in the air, you're concerned about staying in the air, and you want all your problems worked out before you get in the air. All right, so that's a little bit about the drones. So come on over. I've got one more thing to show you. go ahead and keep your distance. I'll take my mask off a little bit so you can hear me a little clearer. This here is an Arduino. What those drones run on is Arduino based. And one of these little chips here is the microcontroller. And here, if you want to get a shot of that, this is coding. And here we see a servo command that's going to cause it to go to a certain location, wait 1,000 milliseconds, move to a different location, and wait. It's going to work a servo motor back and forth. This is a servo motor, and it's going to make it just cycle back and forth. So we use this Arduino to teach people how to code. I've had students do different things with these. This is a servo motor also. They come in a variety of sizes. The size doesn't matter. Controlling the signal that you're feeding it is what matters. And this student, they actually loaded, or mounted, if you can see that, that's out of a laser pointer. Because they want to take a laser pointer, they wanted to shine it up on the wall, and they wanted to spell out their initials. It's just a project. It's just stuff. If you go online, you'd love it. You search, go to YouTube, and put Arduino in there, and you see all kinds of projects of what people are doing. Here's some of the parts we put into it. We have LEDs, different colors, hook up to it. You can operate a simple DC motor. Here, those are all outputs. Here's an input, a switch is an input. This right here is a temperature sensor. It tells you what temperature it is, accurate within like 1/10 of a degree. You can turn something on, turn it off according to temperature. This is interesting. This is a variable resistor. And so between the contacts is a certain amount of resistance, and that goes back to AC/DC, what we learned. But if you put this inside of a glove, when you bend it, when you flex it, the resistance changes. And you can see that in your program. So if you want to bend your finger like that and tell the program to move a motor like that, you can do that. There's lots of that's there, but if you get my drift, you move your finger and the motor turns. I mean, the amount of what you can do is almost limitless. This is a capacitive sensor. It's another input. You put your finger on it, you slide it back and forth, and its output varies. We have some IC chips you can hook on with the Arduino. We've got a potentiometer, like you'd have on a volume controller or something. You can vary things. We have relays that you can go with the Arduino to turn on something more high power. Kind of cool in here. I don't know why I like it so much. We got buzzer goes with it. This right here, I know it's probably going to be pretty hard to see. This is a motor. I'll give it a white background. This is a motor. And that motor has a little tiny weight on it. And that weight is offset to one side. So when you spin it, it vibrates. Well, that's what's in your phone. That's why your phone vibrates when it goes off, because it got a little tiny motor in there. So I thought, what the heck, let's include one of those in this kit so we get to play with it. Oh, one more. This is an input. This is a photoresistor. When the amount of light that hits it changes, its resistance changes. And we can see that with this Arduino to program it to do whatever you want to do. Lots of options here. We've only shown you a part of what we teach. And I don't know, it's a constant challenge, you know. We're going to start with how a flashlight works. We're going to work up into all these components and how you control them with coding, because we live in an automated world. And that is today, and that is the future. And that's where we want our students to be. So I thank you for hanging with us. And if you have any questions or want to know more, just get in contact with us. I'm Mr. Rogo. This is Robotics and Electronic Automation. And thank you.